So we're talking about this graph and the hole that's in it, but we also need to understand, what is this graph showing you? What does it mean? Take a moment, pause, write down, I have cat hair on there, write down what you think this graph means. What is it showing you? Okay, hopefully you have written down what this graph means. So I'm going to tell you a couple of things that the graph does not represent. This does not represent the altitude of the probe, because the probe does not start at 2,193.75 meters underground and then go down. It's not the altitude of the probe. It is not y of t. It's not the height of the probe. Is it the velocity of the probe? Is it the speed the probe is going? It starts out at negative 2193.75 meters per second at time t equals 0, and then the speed becomes increasingly negative because it's going down faster and faster. Is that what this graph is representing? Remembering that this part doesn't mean anything? No, it's not the velocity. Now, by the way, we know that the y of t, the velocity, was the height was 120,000 minus 1.17 t cubed. All right? That's what y of t is. That's not what this is a graph of. By the end of October at the latest, you will be able to look at this position function, this height function, and say, I know what the velocity is. It's negative, what's 3 times 1.17? It's negative 3.54. Negative 3.54 t squared. That's the velocity. You'll be able to get that immediately like that. That's one of the things that we do with calculus, but not yet. All right, so again, this is not a graph of the velocity. The velocity is going to start at, according to this, is going to start at 0 at time t equals 0 and gradually be a downward facing parabola. This is a downward facing parabola with its vertex at the origin and does not have a hole in it. That's not what we're looking at. What we're looking at is a graph of the velocity at a specific time, v of 25, so the velocity at 25 seconds, as calculated with a time interval of delta t. All right, so it's not telling you anything about how the velocity or the position is changing in time. It's telling you how your calculated velocity varies with the interval length. So the longer a length you use centered around delta t, the lower a velocity value you're going to get. And the hole in the graph is if we had delta t equals 0, delta t equals 0 would give you the instantaneous velocity if there were a value there, but there's not. So basically, what calculus is going to do, and when we develop the idea of the limit, which is coming next, is it gives us a way to fill this hole in a way that makes sense, is mathematically sound, and practically useful. You can look at this graph and say, clearly, if I want this function to be continuous, which we're going to define very carefully, I need the value at delta t equals 0 to be r of delta t equal to negative 2193.75. So that's like a rough mathematical way of saying why the instantaneous velocity, v of 25, really is negative 2193.75. So v of 25 really is negative 2193.75. You can think about, if you want, why using a longer time interval gives you decreasing speed. I mean, what does it mean as I move this way in the delta time axis? So if I think of time, right, centered, remember all the intervals are centered at t equals 25, all right? So increasing, going to the right along the delta t axis means I'm taking larger and larger intervals. So does it make sense, really, that a larger interval will always give you a lower velocity calculation? Only if the velocity is decreasing in such a way that it gets very heavy on the negatives over here, whereas over here that velocity is sort of not accelerating as much. So that when you take broader and broader intervals, you're catching more of the time where the velocity is changing the most rapidly. So we're actually going to develop vocabulary to quantify everything that I just said. For now, we can just talk about it qualitatively. So the last thing to say Calculus is about filling this hole. Calculus is going to be all about those holes. In Algebra 2 and pre-calculus, you said, the hole is a place you cannot go. This is undefined. You can't go there. There's nothing there, all right? So calculus is going to allow us to fill the hole. A last thing that I want to ask about it is, how big is the hole? How big is the hole? Think about that for a while. We draw it with a little circle like that, right? I drew it with a little radius. What is the actual radius of the hole? Think about that for a while and then come back. Now, hopefully you have thought about that for a while. How big is the hole? What is the radius of this hole? If I move any positive amount at all in any direction from the hole, I am no longer in it. Therefore, the radius of the hole is 0. It is but a single point. All right, I think we're finally ready to go to limits number 2.